And this video is about majority voting, which is a method of error correction. So correcting errors is quite important in computer communication because we can't guarantee that every time we send a signal it's going to be exactly correct. So when we tend to think of binary numbers and binary signals, we tend to think of it this way with a voltage and time like this, and we can represent a 1 with a higher voltage and a 0 with a lower voltage, etc. But in the real world, it ends up more like this chart on this side. So we've got a 1 and a 0 and a 1 and a 1 and a 0 in this case. Then you can see the signal is degraded. So sometimes the signal degrades by attenuation. So attenuation is just where over a long cable the power reduces as you go further. It can be obviously regenerated part way along so that it doesn't go right down to 0, and that's absolutely fine. You can keep doing that, but sometimes you get an error in the signal, and that error in the signal, it's useful if we can detect it. So one way of detecting that, or trying to detect it, is instead of sending just one copy of each bit, we can send an odd number of copies, so perhaps 3 copies. So the first bit here we might send 111, it's reading as a 1, and the second one we'd send 000. If as we're going along, one of these ends up at not all the same, so we've got this one here 011 and this one here as well 011. So these two, what the system's going to do is count the ones and decide that there are more ones than zeros, so the likely output for this one is 1 and the likely output for this one is also 1, 2. So majority voting just has 3 copies of each symbol in order to try to detect errors. Downside of that, of course, is we've got to send 3 times as much data as we would have done if we weren't doing majority voting error